Good morning, students. As we are discussing exercise 10.3 of chapter straight lines, and we have to start with sum number 9. In sum number 9, we are given two lines. Okay, these are the two lines given, and we have to find the angle between these two lines. Now, we have done the formula, and the formula we have done like if we know the slopes of the lines m1 and m2, right, then angle theta is given by this formula. Tan theta is equals to modulus m2 minus m1 divided by 1 plus m1 m2. It can be m1 minus m2 also, m2 minus m1 also we can take. So this is basically the formula to calculate the angle between two lines. Okay, but here we are not given the slopes, we are just given the equations of the lines, right? And now from these two equations we can calculate the slopes. Okay, as you can notice here, if I just take the equation of line L1, this is y equals to minus root 3x plus 1. So from here the slope will be minus root 3 because the coefficient of x will give you the slope. Similarly, second line if I take, it is y equals to minus 1 by root 3 into x plus 1. So here what is the slope of the second line? Minus 1 by root 3. Okay, if I know these two slopes, okay, we can apply the formula to calculate the angle. So we will write down, therefore tan theta will be equals to modulus of m2 minus m1, that means minus 1 by root 3 minus root 3, so minus minus it will become plus, okay, divided by 1 plus m1 into m2. So it is 1 plus the value of m1 is minus root 3 and the value of m2 is minus 1 by root 3. Okay, so tan theta what we are getting, it is modulus of minus 1 plus 3 whole divided by root 3 divided by root 3 and root 3 will get cancelled. So this is plus 1, 1 plus 1 is 2. Okay, so this is equals to tan theta is equals to modulus of, it is 2 divided by 2 into root 3, that is 1 by root 3. So what we are getting, that tan theta is coming 1 by root 3. Now we know at what angle theta will be equals to 1 by root 3. It is tan of 30 degree. Okay, so we will say it implies theta will be equals to 30 degree. Now remember, whenever we calculate the angle between two lines, the pair of lines will always make the supplementary angle. So the other angle it will be if theta is 30 degree, the other angle, its supplementary angle will be 180 minus 30. We will write down also theta can be 180 degree minus 30 degree, that means this will be 150 degree. So angle will be either 30 degree or 150 degree. One angle we will calculate with the formula, and acute angle we will get this way, the other angle obtuse we will get by as its supplementary angle. Okay, so this is sum number 9, very simple sum. From the given equations of the lines we are just calculating the slopes because we have only this formula in this chapter to calculate the angle between two lines. Okay, once we know m1 m2, we are putting the values to calculate the angle. So this is sum number 9, right? Sum number 10 and 11 already you people have done. Now we will move to sum number 12. Sum number 12 is two lines passing through the point 2, 3 intersect each other at an angle of 60 degree. Okay, so we have two lines L1 and L2, both are passing through the point 2, 3 and they intersect at an angle of 60 degree. This condition is given to us if slope of one line is 2. Okay, if I say, if m1, okay, let us say m1 is 2, then we have to find the equation of the other line. m1 is given 2, and what we are supposed to find, we have to find equation of second line, that means equation of line L2. L1 and L2 are passing through the 2 points, okay, passing through the point. One point is given, the slope of L1 is given. So slope of L1 is given, angle between two lines is given. So with the help of these two things, angle and slope, we can calculate the slope of L2 line, that is M2. And once M2 is calculated, point is there, slope we will calculate, point slope formula we will apply to write down the equation of second line, that is L2, right? So now we will write down as theta equals to 60 degree, m1 is equals to 2. We will take, let the value of m2 be m, and this m we will calculate. Okay, let us apply the formula. So here we have, as per the formula, we know tan theta is equals to modulus of m1 minus m2 divided by 1 plus m1 m2. Okay, theta is 60 degree given, so tan 60 degree is equals to modulus of, this is 2 minus m divided by 1 plus 2 into m, because m1 is 2, m2 we are assuming, let it be m. Okay, now tan 60 degree means tan pi by 3, we know it is root 3. Now since we have to calculate the slope m, and this slope can be negative, can be positive, so when we are removing the modulus, we will consider both plus minus sign. So it will be 2 minus m upon 1 plus 2m, and we will take both the signs, plus sign and minus sign, to calculate the value of m. Okay, so if I consider first of all positive sign, this will be equals to root 3 into 1 plus 2m is equals to 2 minus m. That means root 3 plus 2 root 3m equals to 2 minus m, and you people can calculate it easily. This will be 2 root 3 plus 1 into m equals to 2 minus 3. So the value of m is coming 2 minus root 3 upon 2 root 3 plus m. This is the first slope. Okay, and the second slope, what will be the second slope? If I just take the minus sign, so here the sign will change, and correspondingly the minor change will come in the value. You will take the minus sign here, and corresponding to that, the value of m will be root 3 minus 2 divided by 2 root 3 plus 1. Okay, root 3 minus 2 divided by, okay, minus sign here also, sign will change, 2 root 3 minus 1 will become. Okay, so this will be the formula. Okay, one second. Yeah, minus sign, okay, I have made some mistake here. M will become, only minus sign will come with one term, so it can be written as root 3 plus 2 divided by root 3 plus 2 divided by, it can be 1 minus 2 root 3. So this will be the second slope. So one slope value is this, second slope value is this. So point is given, the point through which both the lines are passing. So point we will use this for the line L2. Slope we will use this slope also to write down the equation. Second slope also we will use to write down the equation, corresponding to which we will get two equations of lines. So let us write down the equations of the line L2. We will write down, therefore, equation of line L2, first of all with point 2, 3, and the first slope. What was the value of the first slope? First slope we have calculated 2 minus root 3. 2 minus root 3 divided by 2 root 3 plus 1. Okay, so the equation will be y minus y1, that means y minus 3 equals to slope 2 minus root 3 upon 2 root 3 plus 1 into x minus x1, means x minus 2. This will be our first equation. Or the second equation, point will remain same, slope will change, and the value of slope is 2 root 3 divided by 1 minus 2 root 3 into x minus 2. Okay, so these two will be the equations of the line L2, corresponding to two different values of the slope. Point will remain same. Okay, so this sum number 12 is also based upon slope, so sum number 9 also we have done based upon angle and slope only. Now next sum we will discuss, sum number 13. Find the equation of right bisector of the line segment. Okay, so sum number 13. So what is given to us? We have to find the equation of right bisector. It is the bisector first of all, that means it is cutting the given line into two equal parts. Second, it is the right bisector, that means it is cutting the line. For example, this line is given which is passing through 2 points, and the 2 points are given to us 3, 4 and -1, 2. Let us say this is -1, 2 point, this is 3, 4. Now bisector is there. Perpendicular means bisector which is cutting the line AB, the line joining the points AB at right angle into two equal parts. Okay, so we will write down L is the right bisector of line segment joining the points A -1, 2 and B point is given 3, 4. These are the 2 points given to us. Now since this is the right bisector, we need two things here. First of all, if this line, the equation of this line we are supposed to calculate. If I can calculate the point, if this point I can know, that means this will be the point which is lying on the line L also, and if I can calculate the slope, I will be able to write down the equation of line. Since this is L is perpendicular to AB, so the slope of AB will be the negative reciprocal slope of L. So slope is calculated, and this point, if I say let it be point P, this point P also we can calculate because it is the bisector. Okay, so P point will be the midpoint of AB line segment. So both the things we can calculate easily. We will use these two things only. We will write down as L is perpendicular to AB, therefore slope of L will be negative reciprocal of slope of AB, okay, which is equals to -1 divided by. Now slope of AB means the slope of the line passing through 2 points. This is x1 y1 point, x2 y2 point. So 4 minus 2 divided by 3 minus -1, so 3 plus 1. So what we are getting here, -4 divided by 2, that is -2. So this will be the slope of the line which is -2. And P point coordinates, let us calculate the coordinates of P, x1 y1. This will be equals to the midpoint of the line segment joining the points AB. So this will be -1 plus 3, that is 2 divided by 2. 2 plus 4, that is 6 divided by 2. So the coordinates of point P will be 1, 3. We will write down therefore equation of right bisector is, it will be y minus y1, that means y minus 3, slope is -2 into x minus x1. So what we are getting, it will be 2x plus y plus 2 minus 5 equal to 0. So this will be the required equation of the right bisector of the line segment which is passing through 2 points. So again and again we are using the same concept, the relationship between the slopes. If the lines are parallel, slopes will be equal. If lines are perpendicular, slopes will be, the product of the slopes will be -1 and so on. Okay, same thing we are doing again and again, right? The next sum is now sum number 14. Find the coordinates of the foot of perpendicular from the point to the line. Sum number 14. Coordinates of the foot of perpendicular from the point to the line. If I say this is the line L, the equation of the line is given 3x minus 4y minus 16 equal to 0. One point is there, point P. The coordinates of this point are -1, 3. We have to find, if I throw the perpendicular from this point P on the line L, let it be M. Okay, so what we are supposed to calculate, we have to find coordinates of M point. You have to find the coordinates of M point, and this M point is lying on the line. So if I say let this point M be x1 y1 point, and x1 y1 point we are supposed to calculate, so that x1 y1 point will satisfy the equation because it is lying on the line. So we will say let, I will just give you the hint, you people can do that. Let the coordinates of M be x1 comma y1, so it will satisfy the equation of line L, that is we will get 3x1 minus 4y1 minus 16 equal to 0. Okay, so when the line, if it is passing through this, means satisfy, we can mark it as 1. So if it is satisfying, this is the equation. Now PM, it is perpendicular to the line L. So slope of this PM will be the negative reciprocal of the slope of line L also. As we are supposed to calculate this foot of perpendicular, this M, that means this is nothing else but this is the point of intersection of the line PM and L. So we have to calculate actually the point of intersection only of these two perpendicular lines, right? So once again, we will use the concept of slope first of all to calculate the slope of this line PM. Once slope is there, point is there, I will get the equation of the line PM. So two equations will be there, and if I solve these two equations simultaneously, that means this equation and the other equation that we will get from here, okay, so that these two equations when we solve together, we will get the intersection point, that is x1 y1, right? So we will write down slope of PM will be negative reciprocal of the slope of line L. Now what is the slope of line L? As we know, this is the equation in the general form. So the slope will be negative coefficient of x upon coefficient of y. So this will be minus 1 upon minus 3 by 4. That means the slope of PM will be 4 by 3. Okay, so slope of PM is calculated 4 by 3, and the point is also there, means P point is there. We can write down, therefore equation of PM is, what will be the equation, or P, it is point is minus 1 comma 3, slope is this, so it will be y minus 3, slope 4 by 3 into x minus minus 1. So we are getting here 4x minus 3y minus 9, and this is 4 plus 9, what we will get here, minus 9, okay, plus 1, 4, and this is minus 3 into 3, 9. So what we are getting here, okay, 1 second, I think minus 1 upon slope of L we are writing, so it is 3 minus 4, so negative coefficient x upon coefficient of y, so we will get here minus 4 by 3 only. Okay, so let us rewrite this equation. We will get minus 4x plus 3y, so it will be 4x plus 3y minus 9 and plus 4, so this will be equals to minus 5 and 0. Okay, so this 4x plus 3y minus 5 equal to 0 will be the equation. This is wrong only. Now this is the equation of the line PM. Okay, and M we have to calculate, and we are assuming M is the point with the coordinates x1 y1. First we have said this point is lying on the line L, so it will satisfy the equation of L. Second, this point is lying on PM also, so it will satisfy this equation. We will write down here M point with the coordinates x1 y1 will satisfy the equation of PM as well. Okay, so what we are getting, that is we will get 4x1 plus 3y1 minus 5 equal to 0. So point we have got. Now the point which we are supposed to calculate x1 y1, in this x1 y1 we have now two equations. So if we solve these equations 1 and 2, we will get the value of x1 and y1. I hope you people can solve it. Okay, I'm repeating what we have done. We have the perpendicular from the point P on this line L, and we are supposed to calculate the foot of perpendicular, that means the coordinates of this point M where this perpendicular is touching the line. Actually it means we are supposed to calculate the intersection point of this perpendicular line to the given line L. Okay, L1 line is given to us. The second line first of all we will calculate, because if we have to find the foot of, means find the intersection point, I must have the two equations. So second equation we are getting once again by using the concept of slope, and once we are getting the equation, these two equations when we are solving, we are getting the intersection point. Okay, this is sum number 14. The next sum is sum number 15. Sum number 15 is the perpendicular from origin to the line meets it at a point minus 1 comma 2. Now one line is there, y equals to mx plus c, and we have the perpendicular from the origin to this line. Okay. So the statement goes like this. We have here one line is given, let it be this line L, and the equation of line is given y equals to mx plus c. This is the line from the origin 0 comma 0, this is origin. A perpendicular is there which is meeting this line at the point minus 1 comma 2. If I throw the perpendicular here, this is the point, let it be P. The coordinates are given minus 1 comma 2. You have to find the values of M and C. Okay, you have to find the values of M and C. Now first thing, you know, this OP is perpendicular on the line L. Okay, so that means the slope of this line will be the negative reciprocal of the slope of OP, because these two lines are again perpendicular. So M is nothing else but M is the slope only. Okay, so once I calculate the slope, second thing, this point P is lying on the line L, so it means it will satisfy the equation of this line. Okay, so these two things only we will use to get the values of M and C. I will just give you the hint, I am just starting it, you people will be able to complete it. We will write down here, you know, as OP is perpendicular to L, therefore product of their slopes, or the slope of L will be negative reciprocal of slope of OP, or we will first of write down slope of OP. What will be the slope of OP? Two points are given. This is, let us say it is x1 y1 point, this is x2 y2 point. So slope will be equals to 2 divided by minus 1, that is minus 2 only. So which implies slope of line L. What will be the slope of line L? It will be negative reciprocal. So minus 1 upon minus 2, it will be 1 by 2. Okay, so the value of M, it means therefore M is 1 by 2, because the equation is given in the slope intercept form only. This is the slope, C is the intercept. M is calculated. Now next thing you have to find C. The point P is lying, we will write down as P lies on the line L, so it will satisfy the equation. Okay, so let us substitute. If it is satisfying the equation, it means we have 2 equals to mx, the value of x is minus 1, okay, plus c. So we have 2 is equals to minus m plus c, and the value of m is already calculated. What is that? It is 2 equals to minus 1 by 2 plus c. So the value of c will be 2 plus 1 by 2, that is 5 by 2. Okay, I was thinking of giving you the hint only, but fine, we have already done the sum. So the value of c will be 5 by 2 and the value of m is also 1 by 2. So Once again, we are just using the concept of slope only. OP is perpendicular to L. So this M will be negative reciprocal of the slope of OP. That first of all, slope of OP we have calculated. So slope of L will be negative reciprocal, that is 1 by 2. M is calculated. P point is lying on the line, so it will satisfy the equation. M if I put, I am getting the value of C. So this is your sum number 15, right? Now next is sum number 16. Let us discuss that. Sum number 16 is, if P and Q are the lengths of perpendiculars from the origin to the line. So we have two lines. Let us write down the lines. First of all, L1 line is x cos theta minus y sin theta equals to k times cos 2 theta, and the second line L2 is given x secant theta plus y cosecant theta equals to k. What is given? P is the distance of L1 line from origin. So origin is the point 0 0. L1 line is given, let it be capital L1 only. So we know the distance formula from of the point from the line, and Q is given the length of perpendicular. Length of perpendicular means the distance only, distance of L2 line from the origin. Okay, length of perpendicular means distance only. So that formula we will use. Now we know the formula. Distance formula is given by mod of ax1 plus by1 plus c divided by root of a square plus b square. This formula only we will use. P is given, Q is given. That means for the first line the distance value, the d is P. For the second line distance is Q. We will just use that, and we are getting our what is that? The relationship. What we are supposed to prove here? Okay, we have to prove that P square plus 4 times Q square equals to K square. This is what we are supposed to calculate. So we will just apply the formula. P is equals to modulus of ax1. What is A? A is cos theta. X1 is 0 0. What is B for the first line? B is sin theta, and y1 is again 0. C is minus k cos 2 theta. Okay, so here we will write down cos theta into 0 minus sin theta into 0 minus k times cos 2 theta. This is the value of C divided by root of a square plus b square. A is cos theta, so cos square theta. B square is sin theta, sin square theta. So P is coming 0 0. K cos 2 theta means k cos 2 theta. Sin square theta plus cos square theta is 1. So this will be 1. So this is the value of P. We will mark it as 1. And now we have Q. Q is given equals to modulus of. Q is the distance of second line L2 from the origin. Origin again 0 0. So A is now secant theta. It will be secant theta into 0 plus cosecant theta into 0 ax1 plus by1. x1 y1 are 0 0. X is A is cos secant theta, B is cosecant theta, plus C. So it will be minus k divided by again root of secant square theta plus cosecant square theta, right? So Q is becoming 0 0. It is k divided by, now root of, secant square theta means 1 upon cos square theta, and this is 1 upon sin square theta. So sin square theta plus cos square theta 1, and this term will go to the numerator k. It will be sin theta cos theta divided by 1 only. So we are having k sin theta cos theta as the value of Q. Is this done? Right. Now P is calculated, Q also let us write down. So Q is k times sin theta cos theta. This is the value of Q. Let us mark it as 2. P and Q we have calculated. We have to prove P square plus 4 times Q square is equals to K square. So let us substitute the value of P and Q in the left hand side and see is it coming equal to K square or not. P is K cos 2 theta and Q is K times sin theta cos theta. Let us substitute. So we will put values of P and Q in the left hand side of P square plus 4 times Q square equals to K square. So let us take LHS. P is what we have calculated. P was, let me check again, K cos 2 theta and K sin theta cos theta. K cos 2 theta square 4 times. The value of Q is K times sin theta cos theta square. So squaring when we do, it will be K square into cos square 2 theta. Because angle will not be squared, only function will take the power, and K sin theta cos theta, K square will come and sin theta cos theta square will be there. And you know, if this 4 I bring it inside, it will become 2 sin theta cos theta, and 2 sin theta cos theta is sin 2 theta only. So this I will get K square sin square 2 theta. So if I take here K square common, we are getting sin square 2 theta plus cos square 2 theta, that is 1 only. So we are getting RHS. How we are getting this thing, let me elaborate here. You know, if this 4 which is in outside K sin theta cos theta square, if I bring it inside, it will be K 2 sin theta cos theta whole square. So it will be K square 2 sin theta cos theta means sin 2 theta whole square. So which is K square sin square 2 theta. This is what we have done in this step. Okay, and we are getting the answer right now. Sum number 17 is in the triangle ABC with the vertices ABC are given. Find the equation and length of altitude from the vertex. I hope you people can do this sum. If this is the triangle ABC, you have to calculate the altitude. That means I will throw the perpendicular from A on the opposite side BC, let it be L. You have to find the equation of altitude and length of altitude. So I am leaving it for you people to find equation of AL and the next is length of AL. How we will do? L, you know, L point is there. AL is perpendicular on BC. So once again, slope concept you will use. The slope of AL will be negative reciprocal of slope of BC. Slope is calculated, A point we know, equation of AL you will write down with the help of slope point formula. Equation is done. Now the distance means, the length of AL means the distance of point A from the line BC. So the distance formula of the point A on from the line BC. So equation of BC you can write down easily, and that way you can do. So this sum I am leaving for you people, sum number 17. And sum number 18, if P is the length of perpendicular from the origin to the line whose intercepts on the axis are A and B. Okay, let me explain the statement. So sum number 18, we have here our system. Okay, one line is given whose intercepts on the axis are A and B. Okay, so if I say this is the line L, this is the point A comma 0 x intercept and y intercept B is given. So it means the equation of line L is x upon A plus y upon B is equal to 1. Okay, P is the length of perpendicular from the origin to the line. From the origin we are throwing the perpendicular over here, and this is the origin O with the coordinate 0 0. This is P. P is the length of perpendicular from the origin to the line. Okay, we have to show that we have to show that 1 upon p square is equals to 1 by a square plus 1 upon b square. Perpendicular distance is there. So distance of the point from the line is there. So which formula we will use? Directly distance of the point from the line formula if I use, we are getting this relation. Line is there, point is there, distance is also given, it is p. So we will write down as d equals to modulus of ax1 plus by1 plus c divided by root of a square plus b square. So d value is given p here, so p will be modulus of, the value of a is here 1 by a, the value of b will be here 1 upon b, c is minus 1. x1 y1 from the origin it is, so x1 y1 is 0. It will be 1 upon a into 0 plus 1 upon b into 0 minus 1 divided by root of a square, that means 1 upon a whole square, b square means 1 upon b whole square. So what we are getting, p is equals to 0 0 1, 1 divided by root of 1 by a square plus 1 by b square. Required part is 1 upon p square. We are having the value of p, so I want the reciprocal 1 upon p square, and square root is not there. The terms 1 upon a square, 1 upon b square are there. These are in denominator inside the square root. So first of all, if I square both sides, I will get p square equals to 1 upon 1 by a square plus 1 by b square. And if I take the reciprocal, I will get 1 upon p square. This will be equals to 1 by a square plus 1 by b square. That's it. Okay. So this is our answer. So again, almost in all sums, again and again, we are using the same concept of slope, equation of line using the slope and point form, and then the distance of a point from the line. That's it. Okay. So with the help of these things, we have completed our exercise. So I hope you people will finish your work, and the exercise is over, and with this our chapter is also over, right? Thank you, students.